Hi, and welcome back. In the last lesson, I asked you to print out a bunch of prime numbers, so the program would do something like this. If I type in 100 here, it would show me all the prime numbers up until 100. And I said to do this, I had two functions. The first function checks if every number from 0 till 100 is prime or not, and then the second function prints it. So let's have a look at the code. So the first function is prime x. You pass it any number through the parameter. If it's 0 or 1, it's going to say false because we know 0 and 1 cannot be prime numbers. After that, it checks if every number up until that number is divisible. If I is bigger than 1 and x is divisible by it, then return false. If this whole for loop continues and never returns, that means that there is nothing divisible before it. So we return true at the end. And prime still is a simple function. It basically calls all the numbers from 0 up until that number, checks if that number is prime using this function, and then prints it. And then this is just the first few couple of sentences that says print prime printer, asks for a number, and then calls primes underscore till, and then passes the number that the user enters. So that's what my code looks like. I will provide the solution in the description below, and let's move on to the next lesson. So, we have already learned about functions and how complex but useful they can be. Today, we will learn how to make functions easier to understand for people reading your code. To make our functions easier to read and understand, we can add type annotations to our functions. Type annotations provide the type of the value that a variable is expected to be assigned. To add a type annotation to a variable in the parameter, we write a colon right after the variable and write its type. This indicates that the value that should be passed to the function through this parameter should be of that particular type, as the function is written to deal with that type of value only. To indicate the type of value that the function returns, we do so by writing a dash and a greater than symbol and the type that will be returned after that. This needs to be written after the set of parentheses and before the colon. The type that we write is the name that Python uses for the types. So we write int for integers, str for strings, list for lists, and etc. However, I do want to point out that type annotations are not checked in Python, like they are in Java or C++. Python would not raise an error if the wrong type of value was passed to a function, but other languages would. C++ and Java are called statically typed languages for this reason, as they check for type of value before assigning it to a variable. We can add comments to our code that Python just skips over. They're only meant for the person reading the code to read and understand what the code is doing. We can add comments to Python by starting the sentence with a number sign, also known as the pound symbol. Every new line of comment needs to start with the number sign for Python to skip over it. If you want to add more than just a few lines of code to comment, it will get tedious to use the number sign again and again. In this case, you can just add 3 single quotes before and after the body of comments. While you can write comments anywhere in your code to describe anything, we use them specially to describe what the functions are doing. Let's have a look at some coding examples now. In today's lesson, we learned about annotation and comments. Let's try to implement them in our code. So let's first make a simple function that prints every item in a list. Let's call it print list, and we'll pass it a function called myList. And what it does is for each in my list, all it's gonna do is print the value out. And if I say print list and then pass it a list for, now all that's gonna do is gonna go over each item in the list and print it. And that's all it does, right? So with annotations, we can describe what my list is. We can say that this is of type list. So right now it's kind of obvious, but it could have been something as simple as just X. And now the list really helps out, like, okay, so the X is supposed to be a list, a parameter. So if we, for example, pass it something else, for example, a number, it's not going to work because it needs to be a list. That's what this function is designed for. It's designed to work with list, and that's what it says here. So let's change this back to a list. Then we want to assign what this function returns. Well, right now this function doesn't return anything, so we'll just type in none. If instead this function was, let's say we had another function called add, and we were taking x and y, and we were returning, let's just write the function first, return x plus y. Now obviously we would need to specify that needs to be an int. This also needs to be an int, and now we would say, yeah, this function ends up returning an int as well. So it says it takes an int, that's the first parameter, then another int as the second parameter, and then it returns an int, which it does, because x plus y, the sum of two integers would be an int as well. And that's what happens here. Now, this tells you about the parameters and what it returns, but doesn't really tell you what the function actually does. Sometimes the name of the function is a hint, but sometimes it's not. So I could just call this function 2, which is a bad. Usually you want to name your functions with what they're supposed to do, but sometimes you can't. So in that case, we just add a comment to the function. We can say this function adds the 2 and returns the value. Now look here, this is like a simple description of what this function does. Now imagine if this function was like 100 lines of code. This one simple function would let you know, instead of looking over all those 100 lines, this would let you know what the whole function is doing. So that's where comments come in. Now this line right here, even though I've written it and you can see how it's like grayed out, it's not actually run. Like Python just skips over this line because it's seen as a comment. Now I can keep adding this line again and again without having much effect on the code itself. So I can have it 4 times and Python would skip over every single one of them. But when you don't want to use a number sign because you have all of these together, so in that case you just use 3 single quotes at the start of the comment block and at the end of the comment block, and Python will skip over them the same way. So let's see what happens. Let me just call this function, let's say function 2, and let's pass it 3 and 4, and I'm going to print whatever the function returns. So we expect to see 7 printed here. Let's remove this one. So we talked about comment, right? Now instead of deleting it, I could just comment it out, and now this won't run. This is another debugging technique that people use. Like instead of removing the code completely and then figuring out that it's not what the problem was and coming back to it, you can just comment it out and figure out what the problem is. And if it's not this line, then you can just bring it back. So there you go, and it just prints out 7, and see how it skipped over this line right here because because it's considered a comment. Now I can write an actual code here, but it's not gonna do anything with it because it's gonna think it's a comment. So hopefully this gives you a good idea of how annotation and comments work. Let's look at today's problem now. So in today's lesson we learned about annotation and comments. So the problem for this one is I'll provide you the code, and what I want you to do is first annotate the parameters and tell me the type that each function like returns. There are 2 functions here, so you need to tell me the type of the parameter, the type that the parameter can be, and the type that the function returns. After that, I want you to add a description of what each function does. And once you have done that, you can comment it right under the definition of the function. You can just comment it there. And then lastly, the script right now doesn't really work. If I run it, it just says this should not print and an empty list. But what it should be showing is a list of primes up until the number that I've given. So it should print out 2, 3, 5, 7. So the thing is, you cannot delete any bit of code here. You can only comment it out. So I want you to comment out a couple of things and see what is it that you need to get rid of for the output to be 2, 3, 5, and 7. I will provide the starting code in the description below, and I will show you my solution in the next lesson. And I'll see you then.